As camera networks grow, many organizations find that they need to add more servers, more GPUs, more screens, and then often more people. Surveillance requirements are expanding faster than the budgets are. So customers need to find a way to increase their security coverage without the infrastructure costs growing alongside the camera numbers growing.
Scaling AI surveillance across hundreds of thousands of cameras is such a demanding problem because video is one of the most data-intensive workloads. A single camera at 720p already generates quite a lot of data. You multiply that across thousands of cameras and you've got a fire hose of information that all needs to be processed in real time.
The more cameras that we can support per server, the lower the overall infrastructure burden. And that means it's easier to scale across multiple sites. If every increase in camera count forces a similar increase in hardware, the scaling becomes slow and quite often way too expensive. So if customers are spending too much budget on hardware, then that's budget that they can't put into a broader rollout. So they can't focus it on things like response capabilities or general operational improvements.
The main technical factors that limit how many cameras you can run on a GPU. So first off, it's GPU memory. Every model you load, every batch of frames in flight, they consume video memory. If you run a large object detection model across dozens of camera streams, you're going to saturate that memory very quickly. The second is inference speed. The model has to keep pace with the incoming frame rate across all cameras. If you fall behind, you are dropping frames, adding latency, and neither of those are acceptable for real-time security. The least obvious one is everything around inference. So the decoding of video, encoding the output, moving the data between the CPU and the GPU, all of that competes for resources.
We also need to deliver AI in a way that fits into the customer's existing environments and quite often budgets. So in practical terms, it means designing a platform that's really efficient, it's scalable, and you can use large camera volumes on it. So customers can get the most value from the infrastructure that they quite often already have in place.
icetana's architecture has been built to maximize the number of cameras per GPU because scale was part of our architecture from the very beginning. It wasn't an afterthought. There's two sides to it, the models and the pipelines that they run in. On the model side, we have a high performance object detection and tracking algorithms alongside our self-learning AI. We don't use massive off-the-shelf models. We curate our own data sets and then train lightweight, domain-specific models that have a high accuracy and a fraction of the compute cost. Smaller models, faster inference, more cameras per GPU. On the pipeline side, our engineering team, they're all wizards. They have built a custom video processing and AI pipeline from scratch. So decode, inference, encode. They all use different parts of the GPU hardware. So there's dedicated engines for video decode and encode, separate compute cores for inference. In theory, they can all run at once, but in practice, orchestrating all those jobs to execute in parallel, it's not an easy task. It's something that we spent probably the best part of a year perfecting.
We think about scale from the customer's point of view, not just our algorithm's point of view. They're trying to manage their capital costs, the GPU costs, the control room constraints, and any staffing limitations. So our goal is to help our customers increase security effectiveness without having to rebuild the whole operating model.
We're seeing in the industry a lot of competitors support far fewer numbers of cameras per server. We currently support around 200 cameras per server. So that's a 2U server. It's a simple rack and stack to scale it. If you've got 1,000 cameras, add 5 of those units. With some of our competitors, they're kind of in that sort of 80 to 100 cameras per server space. So you're probably looking at about double the infrastructure cost and the space as well. I think the industry's at a turning point. For the last few years, focus has been on accuracy. Can the model detect this? Can it classify that? So accuracy matters, but I think the next phase is deployability. Can you actually run this model affordably in the real world? We'll see the market move away from bigger model, bigger GPU mindset Purpose-built efficient architectures, I think they're going to become the baseline rather than a differentiator.
Organisations that are looking to scale their surveillance operations over the next few years are going to need to think beyond just adding more cameras. So for customers, that means choosing platforms that can help them scale efficiently and solutions that maximise the cameras per server. So we need to reduce dependence on additional hardware and GPUs, and we want to help existing teams oversee much larger environments. The organisations that do this well will be able to expand coverage faster, they'll control their costs better, and they'll get more value from the infrastructure that they already have in place.